Hmm?
So it's really messy. So I think it's wrong.
Messy. Should not be messy, but what's the answer? Okay, I'll do something and I'll come back to this question. Okay. See, if there was a question as simple as like really simple, we are doing basics only this hour. So say this is a ground on which there is a box, there's a block that is going to hit some other block. Say there's another block. Ayo. So say this is m mass. Say this is 2m mass. Say this velocity was u. Say this velocity. This velocity say 3u. Say this velocity, or forget it. This is u, and we have to find the velocity after collision. The velocity was, no, let me put 3u, and this was say u velocity. After collision, what are the velocities? Okay. Hmm? Is that clear? So it can be done with elastic collision, non-elastic collision, I mean inelastic collision, partially inelastic collision. So any which way we do, we can treat it in two ways. One is writing the equations of momentum before collision and momentum after collision. Okay. So after collision, suppose the velocities are v1. I'll make them collide somewhere. Yeah, so after collision, suppose the velocity is v1 and v2. Okay, obviously v2 will be more than v1. Right, guys? So what is the equation you'll write? Tell me fast. Tell me the equation you'll write to get the answer. Quick. Quick. Bolo, somebody, if you don't say, we'll just close this thing and we'll go back up for today.
3mu plus 2mu.
Yeah. M into 3u plus 2m into u. Yeah, keep saying.
Is equal to mv1 plus 2mv2.
Yeah, absolutely right. That is one of the equation we'll write. And the other equation depends on whether it was elastic, non-elastic, or what is the distribution. Right, guys? Equal to mv1 plus mv2. Okay. Now, the same thing, if we consider the body alone, if we consider this body alone, which body alone, and see what is happening to this body. I'm just doing theory, okay? Then how do we look at it? Once again, let me just consider the body alone. That's your body. It had a collision, and after collision, it is this situation. Is that clear? So earlier the equation has been written thinking of the center of mass. The m and the 2m body has got a center of mass, and the velocity of the center of mass initially and finally must be same, and that gives you the above equation. Okay. Now here, so two masses together was the system. Now here alone this body. Then what is happening before and after collision? What is happening is it had a certain momentum, initial momentum. So P initial was equal to m into 3u. After some time, it had, after collision, it got an impact or impulse, and the momentum became m into v1. Okay, how do we connect and write them? We'll connect with respect to how much impulse it got. Okay, so I'll just draw the impulse. At the point of collision, what would have happened? I was going with 3u. What would have happened when it is colliding with the other body? It received a force or not? A impact force, right, guys? And for how much time? For a very small amount of time, right? And the force is not constant. It just touches, there is some force, then it is pressing more, it is high, it becomes high, and it becomes low. The force goes up and down like this. But we don't have to care about the graph and all. It gives a impulse, that is your f dot dt impulse. You don't have to care about this f dot dt also. Okay. You just have to know that it gives a impulse which reduces the momentum. Okay, so that impulse I is equal to f dot dt is given on towards the left hand side, and it is going to kill the initial momentum. The unit of impulse and unit of momentum and unit of f dot dt, as the other person said, Newton into second, is all same unit. Okay, mass into velocity unit, force into time unit is all same. Okay, that's impulse unit. Okay, so what is impulse? Impulse is, what is the impulse in this case? Impulse has been received by the body in the backward direction. It had a certain initial momentum which got reduced, and finally the momentum became this much. So how will you connect and write them? बोलिए, how are you going to write PI, PF and I? How are you going to connect and write them?
Impulse will be change in momentum. PF minus PI.
That is technically right. Yeah, that is correct. But I'll have to write vector, vector, vector. In this case, if I just take the values and I consider I to be f dot dt, and it is backwards, so you are absolutely right. It should be a negative value, but just I say it as a value, say value is 2. The absolute value is 2. Then I can write something like this. I hope you are okay with it. This was the body one, had an initial momentum of 3mu. It got a backward impulse of I, so minus I, where I is a absolute value of I. I can write a mod I. Okay, so that there is no confusion. Is the remaining final momentum? Is that clear? It could have received a backward impulse so high that it could have been going back also. Is that clear, guys? Any doubt in this?
No, sir.
No, sir.
3mu minus I, where I is a value, okay, is equal to mv1. So can you tell me the same kind of story for the other block? What will you do for the other block? How will you write for the other block? The other block before collision was having a 2m mass, was having u velocity. After collision, the 2m mass is having v2 velocity. How will you write it? Initial momentum, I can write it as P2 initial, which is how much, guys?
2 mu.
P2 final, which is how much, guys?
2 mv2.
Yeah, and then how do I connect them with the impulse? It would have got an impulse which side, guys, now?
Forward.
Yeah, this red body is going and coming and going to hit it. Okay. So it hits it and gives it an impulse forward. Will this impulse be ditto same as the previous one, or depends whether it is an elastic inelastic collision or what? Before you answer, this impulse is ditto same as the previous one. Okay, absolutely same as this one. Can you tell me the reason why? Absolutely same as this impulse. Can you tell the reason why? Because Newton said that action reaction force is same. So whatever force was backwards on the red body and increasing like that, same way force is in the front body. First less, then increases, then again becomes less later on. But ditto same, action reaction force. And time of contact of the red and the brown body was same, obviously. So if you integrate over dt, it's the same thing, f dot dt. Is that clear? The only difference is this time impulse is, but the vector of the impulse is forward. Any doubt, guys? Any doubt? So what will you write now as the equation?
2 mu plus I is equal to 2 mv2.
2mu plus I. Yes, absolutely. It had so much of momentum and then it got a I extra momentum and became so much of momentum. Absolutely right. So may I just write the other one? I'll just write for the red body as इसलिए मैं बना के यहाँ पे लिख दूँ कहाँ पे ये कहाँ पे था अच्छा यो 1 second guys. Yeah. Oof, I'm so sorry, man. How clumsy. Come on. I'm doing this so that visually it is good in front of you, but I'm making such a mess of my act that what to do. Okay, so this thing was written for this one. Similarly, for the brown one, I'm going to write it as P2I got an impulse and became P2 final. Okay, in terms of the velocity given over here for this specific case, it is 2 mu plus I. I is the value, absolute value, and which is plus only, so it doesn't matter much over here. Became 2mv2, right? So if I combine the two, if I add the two equations, I add this one and this one. If I add the two equations, what do I get? Or if I add these two equations, what do I get? I and I will get cancelled, right? 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 And you'll
Yes.
get equations of P1 I plus P2 initial momentum is equal to P1 final momentum plus P2 final momentum. This is what you get, right? Or 3mu plus 2mu is equal to m1v1 plus 2mv2, right? Right. So when you write this momentum and look at a single body and write, the impulse comes into the picture and we write in terms of impulse. So in questions, as I said, it is simple collision questions only. If they ask you the impulse, it was definitely the change of the momentum of any one body was the impulse. And depending on which body you're talking about, you'll get the direction, either backwards or forwards. Okay? Is that clear?
Yes, sir.
Yeah. So one could have done this question by writing the impulse on each of body and then cancelling out the impulse by adding up the equation, as I did over here. We added the equation and we got the same equation. So if the question is not asking specifically, you don't have to do it. So now, does this question ask for impulse or something? Okay, I'll ask you three things over here. Okay. What is the impulse by the spherical ball? What is the impulse received by the spherical ball? What is the impulse received by the pan? And what is the impulse received by the block? Are you understanding? If you are able to do that, you are very, very good. Doing the question, it is virtually nothing. Okay. So we'll do the impulse part. They have asked the final speed. It's a simple collision question, so it is virtually nothing. So I'll just do it without the impulse. Shall I do it without the impulse?
Yes, sir.
Okay, without the impulse, the answer is something like this. This situation can be thought of in your mind as if this is the pan, this is the string attached to the pan, and this is the block. Okay, this block. This blue block is this, and this green pan is this. Is that clear, guys? And then there's a bob which comes and hits it, and it is sticking to it, or what? Particle of the pan and sticks to it. Okay. So I'll just write, okay, the initial momentum is how much? Initial momentum is m into what's the velocity? V. Okay. So m into V is the initial momentum. Any other momentum, guys? Any other momentum? Pulley just changes the direction of the force. Nothing else happens over here. Okay. In a pulley, if I'm pulling this down with say F force, then it is as good as I'm trying to pull this up. Is that clear? With the force which is transmitted through the tension and all. Okay. Now, anyways, so this question, initial momentum is mv, final momentum is what? What is the final momentum? How will the situation look like? Finally, the situation will look like this is the gray pan. This is the black bob sticking to it. And then there is the blue block, right? And this one is sticking. So these two will be going with the same velocity, right, guys? Some say v dash velocity. This will be going with what velocity? For JEE and entrance exam, if this is a string, we will consider it as v dash velocity. Highly debatable. All string questions are actually not valid in pure physics. It doesn't happen like that. Okay. In the point, you will never be able to create such a situation that it goes and hits the pan like this and the other guy is trailing with the same velocity. No, it can get an impulse and come with some other higher velocity due to some elasticity in the string. Okay. So we'll consider certain theoretical strings such that if this is going with v dash velocity, this also goes with v dash velocity. That is what all entrance exams are using, particularly in India, Indian entrance exam. So that's the situation after collision. So what do we write for the momentum after collision, guys? What do we write? Anybody? Momentum after collision? Bolo? All of the masses are MMM.
2m v dash,
Why 2M?
because the smaller mass sticks to the band.
And what about this big blue mass getting dragged along with it? That's not the momentum. That blue mass is not having a momentum. Really surprised. I'm really surprised. Small mass goes with a V dash S, V dash. Green is going with V dash. Yeah, V dash. In your mind, you think, okay, it is ticking and hence it is 2M. Then, yeah, you can write that way also. Individually, they are the black body is MB dash, the green body is green MB dash. If you think they are sticking together and they are 2M, yes, then you can write 2M and both going with V dash. Yeah, no problem. What about the blue one? I drew the diagram, right? And the blue also gains the momentum, right? All this gain of momentum is due to the impulse given by the body, right? So the blue M V dash, right? One can say all three are together one body, and you could have said 3M V dash. Whichever way you say, you could have said 3M V dash also. Who cares? All 3M are going with V dash as a single body, single speed. So that's your equation, right? Getting the point, people? Getting the point, people?
Yes.
Yeah, so what's the answer? Answer is V dash is equal to V by 3. End of story. So what is the question? Question has got no merit. I mean, hardly anything in this. Now let me analyze the impulse and write it properly. That is the, if you can write the impulse on each body properly, what is the impulse received by the black body? What is the impulse received by the green body? And what is the impulse received by the blue body? Then I would say really you have done a very good job. Got the point? So try to write that. Try to write that. I'll give you a minute. हाँ बैठ के काम में कौन सा ही क्या आज मुझे खाली है ग्रीन टी दे दो भाई क्लास भैया Done, guys. So how do you write impulse? You think of the force which is acting on the body. You think only of the body. If I'm talking about the black body, you think only of the black body, nothing else. Okay? And then you think of the force. So what is the force which will act on it? Due to the collision, there will be some force. That force is the action-reaction force. So when you think of the other body, you'll use the same force. Is that clear? So I'll get you started with the black body first. So I think we'll be able to, we can manage doing in the same page itself. Okay, I'll think of the black body first. Anybody? If I'm thinking of this first, how did I write? When I showed you an example, ये वाला type का example. When I showed you this, what did I write? I made only the red body first, wrote the initial momentum, wrote the final momentum. Remember the sequence, wrote this, wrote that, and said there is a certain force acting which is going to give an impulse, and I wrote this. Remember that? Same thing you have to do for the black dot body now. Do it for the black dot body. So initial momentum is how much? mv, right? It strikes something. Which way will it get the force, impulsive force, guys? Which way? Bolo, bolo, jaldi bolo. It is going and striking the pan. Which way will it get an impulsive force?
Opposite motion.
Yeah, so you get an impulsive force like this, right? Shall I call it as I or I1? Whatever you say. I1 लिख देता हूँ, okay? I1, first impulsive force what we are studying. Is that clear? And then what happens to the black body? The black body after some time is sticking to the pan and all, I don't care. And it is going with how much velocity? It is going with v dash velocity. So how do I write this equation? How do I write this equation?
mv minus I is equal to mv dash.
Absolutely right. Now this very simple exercise, if you can do for the other two bodies, I'll be mighty, mighty happy, okay? See, nobody said this earlier, and I wrote, you could have said that, "Arey, ye to bata hi dete. What is there? Nothing over here." There's nothing in physics. You have to analyze very carefully. You have to get started in the right way and analyze things very carefully. Yeah, so for the green body, how will you write it? Make a diagram for yourself, write it and tell me. I'll be really happy if you get it right. I'm saying it so much, that means there might be some catch and no problem at all if you don't get it. If you get it part right also, no problem. That's the green body. Was initially having no velocity. Initially, the velocity was 0. And after that, after collision, the green body is having velocity. Yeah, nobody has written. Somebody? Anybody? Written?
I is equal to mv dash. Sanskriti.
Okay, after collision, what is the velocity it gets?
V dash.
Sanskriti 11th or 12th?
11th.
Okay. NTS?
Yes.
Okay. Yeah, so what will you write?
Impulse is equal to mv dash.
Impulse is same, this one, I1
Yeah,
or some other impulse?
same.
Yeah, since I1 is an action reaction, when the black body hit it, it got a reaction left side. So this guy must get it right side, same I1. But Sanskriti, you are not right because you have ignored something. Impulsive, jhatka forces, this jerk kind of forces. One is it got from where it hit. Then do you think it is like it's the same situation whether the blue body was there or not? Would it be the same situation? Obviously not. If it will not be the same situation, then how will this equation work? You are going to say that initially the momentum was 0, m into 0, plus you are saying it got an impulse of I1, and that became the So how is this situation? Equation should translate the whole situation. How is this situation? It's not. What you have solved is a situation as if there was only the black body and only the pan. Then absolutely right. The black body went and hit the pan, and this is what you would have written. You add the two equations, you'll get MV is equal to MV1 MV dash plus MV dash. Yes, guys. So what else can be included? What else is possibly, what else can be included? Impulsive forces. So once the pan gets an impulsive force of I1, it tries to acquire a certain velocity, which according to the Sanskriti's calculation would have been V dash is equal to V by 2. V by 2 is a high velocity. It won't be able to achieve that velocity because it will pull the string badly and the string will give it an impulse again, right? You imagine you take a jhatka and pull a string, the string pulls you back, right? Right? All of a sudden it is trying to pull the blue body through the string will pull it back. So you'll get another impulse over here, I2. Is that clear, guys? Is that clear? The tension is going to rise very, very high as a impulsive force, not as a gradual force. Is this part clear, guys? This is important over here in this question. Otherwise, nothing was important in this question. Is that clear? Is that clear, guys?
Yes, sir.
That when it tries to achieve a velocity due to the pink impulse, it is not allowed because of the blue drag present over there, and there is an impulsive force provided by the string, which is I2. So now what is the equation? What we can write? Tell, guys. Initial momentum and then impulse becomes final momentum. That is how the story goes. So what do you write?
I1 minus I2 is equal to MV dash.
Absolutely right. Who said that?
Sanskriti.
Again, okay, good. Initial momentum is 0. Then you get a I1 impulse. And you get a ulta impulse, ulta jhatka of I2. And eventually this is your change of momentum of the green body. So the green body now has the momentum of MV dash. Is that clear? Now comes the story of the blue body. Now this is like, I hope everybody will be able to write. Just make the diagram and write the two. And I really hope that there is not a single one who is not writing it. Okay. But do make the body. So now I hope you understand when I say make the body, you'll make the tiny string also. And then repeat the same body before collision, after collision, do everything. Okay. You may think it is waste of time, but ultimately if you're doing properly, you get right answer, it's not a waste of time. So initial velocity was 0. Now it gets a velocity of V dash. This is assumed. Okay. Now what do you write, guys? What do you write? Anybody? Apart from Sanskriti? What will you write? What is the impulse it is getting now? Yes, people? When this string pulls this thing back, okay, because it was trying to drag the blue body, this is getting pulled forward, no? Right? It is absolutely okay to assume that if the pullback was t and integration of t dot dt, Yo. I'm going to mess my diagram. Set my diagram. One second. No, that's okay. Yeah, integration dot dt, then it's the same t, right? Which is pulling it forward, right? Same t in the same time, same integration, right? So this is again same impulse I2 or not? I1 or I2, guys? I1 or I2? Are you getting it what I'm saying? The string pulled this backwards, so same string pulled the blue body forward, and that is what the impulsive force the blue body received. Somebody speak out. What do you write for the last body? How do you write? What do you write?
Sir, so won't the blue body create like just like how the pan had I2, won't the blue body have an impulse force?
The blue body is having an impulse force. Because of blue body, only the pan had I2. The pan wanted to go forward, and the string it gave a jerk to the string. The string gave it a jerk back. I2 jerk back. So the string is giving it this a jerk forward I2 because string has same tension throughout, equally distributed. I2 was nothing but the tension in the string dot dt integration. So it has to give the same jerk forward also.
Yes.
So what do you write? What do we write? Again, we write the same format. Whatever is the initial momentum of the body plus or minus the impulse it got is the final momentum of the body. That nobody should confuse. We have to write this way, how we were writing. Initial momentum of the, what was that? What was that? Yeah, this one. Initial momentum of the body, then direction of impulse. If it is supportive, very good, add the impulse. If it is ulta, subtract, and that's the final momentum of the body. So what do we write? Initial momentum 0, then impulse, giving it forward motion or backward motion? Forward motion I2 is equal to final momentum. How much is that? mv dash.
V dash.
Now if we add the three equations, equation number 1, equation number 2, and equation number 3, so what do we get? Minus I1 plus I1 gets cancelled from 1 and 2, then minus I2 plus I2 gets cancelled. So ultimately we get mv is equal to 3 mv dash, right? Which we could have got directly, or which we were getting directly just by writing what? Conservation of momentum, which is also the same thing, but through the impulse, we are just having a more microscopic look of what are we conserving, what is actually happening. Is that clear, guys?
Yes, sir.
Even though this question, the question setter would have thought that you are going to do through impulse and all, and it's a difficult question. If you just do through as a momentum conservation, it is not. But momentum conservation is having a trick over here. This body having an upward momentum is say positive, then this body lower downward momentum is positive because string is just making the direction change. So we have to imagine this situation as this situation, then only we could have written this equation. If you don't want to translate this this diagram into this situation and want to write things correctly, then you have no option but to write it this way. Is that clear? Then you have to go impulse by impulse, okay? Or you should have a vision of converting the situation to a linear situation and write that. Is that clear? Is that clear, guys?
Yes, sir.
Yeah. So that's it. If you have doubts, stay back. Otherwise, that's it on impulse. Thanks a lot for attending the class.
Thank you, sir. Thank you, sir.
Mm. Any doubts? Chalo, bye bye then. I'm stopping the recording. If you have any doubt, you ask. Otherwise, you leave.